Welcome to A1 Example 1. What is the sequence of first differences for the linear polynomial given by ax plus b, where a and b are constant coefficients? To begin, we start with the word to the y's. Although you may be tempted to work through example 1 with numbers, using numbers, and instead of a and b, using symbols a and b actually make the structure of the first differences very obvious. Whereas numbers could hide the structure of what's actually going on. Also, when we work with constant coefficients like a and b, it gives us the generalization all at once, meaning we can apply it to all values of a and b. So, to begin, we know that we have values of x and y for our linear, which is y equals ax plus b. So we pick values of x, like 0, 1, 2, 3, and 4, and we can plug them in to x. So 0 times a plus b is just b. 1 times a is a plus b is a plus b. And so we create our list of values from where we're plugging in x, and we put the result there. Now, to find the first difference, we're going to subtract consecutive terms. So, consecutive terms would be 1 and 2. So we can subtract 2a plus b minus a plus b, right? These are consecutive terms. So, the terms of the first differences, or the first difference sequence, are found by subtracting consecutive terms in the sequence generated by the polynomial expression ax plus b, that linear polynomial that we've been working with. So, we get the b, the a plus b, the 2a plus b. And so we do the first term, which is subtracting a plus b minus b. And you get a. And when you do it for the next one, (2a plus b minus a plus b) also equals a. You start to see a pattern here. 3a minus 2a is a. B minus b is no b. So we're left with a. 4a minus 3a is a. B minus b is, we're just left with a. Right? Again, you have to distribute that negative sign to both the negative 2, or to the 2a and to the b to make them both negative. So make sure you're doing that. Right? Also remember that this is where x is equal to 1 and x is equal to 0. That's what's going on here, right? That's where they're getting these values if you go back to that table we created. So hopefully you see the pattern here of a constant first difference, right? The first differences sequence a. This is the sequence that we got, right? From the first term, the second term, the third term, the fourth term. For first degree polynomials, or for linear, first degree or linear, the first difference are constant and equal to a. Or, in another way to say a, is the slope. When we look at the second differences, we're going to subtract the first differences. So if you think about this, we set up a table. The first term was A, the second term was A, the third term was A. Right? These are the first differences. And when we look to the second difference, right, when we subtract A minus A, we're left with 0. And so, since A minus A is equal to 0, the second differences are all 0. Thus, the sequence of second differences is 0, 0, 0, 0. This is a pattern that holds true for all linear or first degree polynomial expressions.